Good morning to all. Am I audible? Can anyone inform? Am I audible? Is my screen buffering? If any disturbance is there, please inform. Okay, then I will start the class. So this today's class is related to the experiments which we can do in the laboratory practically, which I have already recorded and uploaded in my channel. For those experiments, that is Kirchhoff's voltage law and current law. Okay, so I am going to, one second. For Kirchhoff's voltage law and current law, I am going to explain how to verify them theoretically. So I hope you people have scientific calculator. You must have scientific calculator while doing the calculations. You can verify whether the answers that I have been showing you here in the PPT are correct or not. So you also do the calculation so that it will be useful to you. Okay. So if you have doubts, you can mention in the chat box so that I will clarify your doubts. Okay. So let us start the class. So today's class is theoretical calculations for the hands-on experience videos which are available in my channel to verify Kirchhoff's voltage law and superposition theorem. So let us start with Kirchhoff's voltage law and Kirchhoff's current law. So I am going to start with the theoretical calculations to verify the Kirchhoff's voltage law for the given circuit. Okay. So if you remember, this is the circuit for which practically I have done the experiment and have shown you, I have verified the Kirchhoff's voltage law, so that which is available in my channel. Now theoretically, let us see how to verify Kirchhoff's voltage law. Okay. So if you observe here, in this given circuit, I will just expand it. If you observe here, this is one closed path. Okay, this is one closed loop, I can say. Okay, this is one closed loop. You will call this closed loop as a mesh. And this is one closed loop. So you will call this also as a mesh. So how many meshes are there? This is one closed loop. You call it as mesh 1. This is one closed loop. You call it as mesh 2. Okay. So since there are two meshes, two closed paths, we can say this is one closed path, this is one closed path. So we can assume two mesh currents. Okay. Let us assume currents as I1 in mesh 1 and I2 in mesh 2. I'll show you another diagram, another slide. In that slide, I have drawn the mesh current. So you can see here. So you can see this is one closed path. This is one closed path. So this closed path, you call it as mesh 1. This closed path, you call it as mesh 2. Okay. So what is meant by closed path? What is meant by closed path? You can see a voltage source here of 30 volts. Okay. You can see a voltage source of 30 volts. From positive terminal, current will come out. Okay. From the positive terminal, current will come out and it will return back from the source to the negative terminal of the source from whichever it has started. Okay, so whichever terminal current starts to flow, and if it returns back to the same terminal, okay, so then it is known as closed path. Means current has to return back. There must be a return path for the current. Okay, So if there is a written path for the current, that is known as closed path. So here this is a closed path. You call it as mesh 1. This is another closed path. Okay. Call it as mesh 2. Okay. So you in general we can say this is one closed loop and this is another closed loop. So mesh 1 and mesh 2 are two closed loops here. So assume some current I1 in first mesh 1. Okay. Assume current I2 in mesh 2. So this since this is a closed path or loop or mesh we can say, so we will call this I1 as loop current. We will call I2 as loop current. So we are assuming two loop currents, I1 current in mesh 1 and I2 loop current in mesh 2. Okay, so we have assumed two currents, I1 in mesh 1 and I2 in mesh 2. Now if you observe, I have drawn some arrow mark here in both the meshes. Okay, so these arrow marks, if you carefully observe, they are in clockwise or anti-clockwise. You can mention in the chat box. Okay, whether these loops are in clockwise or anti-clockwise. In which direction I have assumed here, clockwise or anti-clockwise? You just mention in the chat box. So if you carefully observe, what you can see is it is in both are in clockwise. So these loop currents are which you can assume in any direction that you want. Okay, you can assume the loop current directions. Okay, these arrow marks are nothing but the direction in which current is flowing. Okay, the direction in which current is flowing. We are assuming some direction. It's our wish. Okay, you can assume I1 current flows. Let us. We are assuming here according to this diagram. We are assuming here that current flows in clockwise direction. I1 current flows in clockwise direction. I2 current also flows in clockwise direction in this closed path. Okay, within this closed path, this I1 current loop current flows in clockwise direction. Okay, if you don't want clockwise, if you want anti-clockwise, you can assume, you can draw. I will take a pen. If you don't want clockwise, you can even assume anti-clockwise. Both currents you can assume anti-clockwise. It doesn't matter. Okay, it doesn't matter. It's not important. Whatever you assume, whatever current direction that you assume, according to that you have to write the equations. Okay, you have to write the loop equations. Okay, so Kirchhoff law equation. Do you know what is the statement of Kirchhoff's voltage law? Here we are going to verify Kirchhoff's voltage law. So what is according to Kirchhoff's voltage law? The algebraic sum of all voltages in a closed path must be equal to 0. Okay, so current directions are our wish. You can assume I1 loop current in clockwise direction. Okay, you can assume I1 loop current in clockwise direction. I2 loop current. My cursor won't listen to me. Okay, I2 loop current in anti-clockwise direction. Your wish. Okay, so directions that we assume here, loop current directions that we assume here is not mandatory, which I am showing you here in this diagram. Okay, whatever I have shown you here, you need not follow this. Okay, I have assumed both loop currents I1 and I2 in clockwise direction. No need to assume in clockwise direction, but if you want, you can assume in clockwise, your wish. So here I have assumed I1 current, loop current in clockwise, I2 loop current in clockwise direction. Okay, so this is it. Now look at this diagram. Look at this diagram. If you see here, this is our I1 current, isn't it? This is our I1 current. Now, what is the current flowing through this resistor R1? What is the current flowing through resistor R1? Current flowing through resistor is, it is a single branch, isn't it? So it is not common to any other loop. Okay, this branch, R1 branch, is not common to any other loop. So therefore, only I1 current. Current through R1 is what? Current through R1 is only I1. Okay, current flowing through R1 is how much? I1 current. Similarly, current flowing through R3. Current flowing through R3 is I2. Okay, current flowing through R3 is I2. Similarly, current flowing through R4 is I2. Okay. Current flowing through R1 is I1. Current flowing through R1 is I1. Current flowing through R3 is I2. Similarly, current flowing through R4, that is 500 ohm, this resistor, is I2. Now, what is the current flowing through 2000 ohms? Here 2000 ohms is there. What is the current flowing through 2000 ohms? See, if you observe carefully, R2 is, that is 2000 ohms, is in between mesh 1 and mesh 2. Okay, R2 is in between mesh 1 and mesh 2. Okay, so here this R2 is in between mesh 1 and mesh 2. Okay, R2 is in between mesh 1 and mesh 2. So it is common. 2000 ohms is common branch for mesh 1 and mesh 2. And you just carefully observe the current directions, I1 current and I2 current. See, I1 current is, I1 current, if you observe, besides to R2, it is downward. Okay. And what about I2 current besides to R2? You just observe this side, it is upward, isn't it? This current, you just complete this path. You just complete this path. Okay, if you complete this path, so this direction, current will flow like this, it will flow like this, it will flow like this, it will flow like this, isn't it? This current also, it will flow like this, it will flow like this, and it will flow like this. This is it. Okay. So, okay. So here if you observe, besides to just observe the current direction, I1 loop current, I2 loop current, besides to R2. So for I1 current flows downward and I2 current flows upward. Both are in opposite direction to each other. I1 loop current, I2 loop current with respect to R2, they are opposite to each other. Therefore, difference of I1 and I2. Okay, difference of an I1 and I2 means I1 minus I2 or I2 minus I1. Okay, okay, so I1 minus I2 or I2 minus I1. Difference of I1 and I2 current will flow through this 2000 ohms resistor. Okay, now let us apply KVL in this circuit. Let us apply KVL in this circuit and let us verify KVL, Kirchhoff's voltage law. Now I am going to consider mesh 1. Okay, I am going to consider mesh 1. We will apply KVL in mesh 1 first. Next, we will apply KVL in mesh 2. Okay, so now I am going to just copy this image. So I have copied it from the previous slide. So this is my circuit, isn't it? Let us apply KVL. Let us apply KVL to this in mesh 1. Okay, applying KVL in mesh 1. What do you get? You just see here. So there, what is there in mesh 1? There is a voltage source of 30 volts. There is a resistor of 47 ohms. There is another resistor of 2000 ohms. Okay, resistor of 47 ohms and a resistor R2 of 2000. R1 is 47, R2 is 2000. So total how many elements are there in this mesh 1? 1, 2, 3. Okay, total how many elements are there in mesh 1? The voltage source of 30 volts, resistance R1 of 47 ohms, resistance R2 of 2000 ohms. Total 3 elements are there in mesh 1. Okay. And according to Kirchhoff's voltage law, the algebraic sum of all the voltage sources in a closed path must be equal to the algebraic sum of the voltage drops in the closed path. So this is my first closed path, mesh 1. I am going to apply Kirchhoff's voltage law in mesh 1. Okay, I am going to apply Kirchhoff's voltage law in mesh 1. So if you apply Kirchhoff's voltage law, you just see what is the voltage across R1? Voltage is V equal to I into R, isn't it? V is equal to what? I into R. What is I value? Current in R1? I1 current. Okay, R1 current flowing in R1 is I1 into what is the resistance? 47. So 47 into I1. Okay. So voltage drop across this R1 is how much? 47 into I1 is the voltage drop. Next, what is another element in mesh 1? Another voltage drop will occur across 2000 ohms. So 2000 into, okay, 2000 into, what did I say? I1 current and I2 current. They are just opposite to each other. I will just expand the screen. Okay, so this I2 current, if you observe, it is flowing like this. And this, I'm sorry, this is I1, not I2. Sorry, I1 current, if you observe, it is downward, and I2 current, if you observe, it is upward. Okay, I1 is downward, I2 is upward. That means difference of I1 and I2. Okay, since we have considered mesh 1 here, I must write I1 minus I2. Okay, since I have considered mesh 1 here, we are applying KVL to mesh 1. Therefore, the voltage is what? R into I. R is what? 2000 is the R. And what is I value? Difference of I1 and I2 is the I value here. Okay. Now, so in this loop, how many voltage drops are there? 2 resistors are there. This is one voltage drop. This is one voltage drop. So 47 into I1 plus 2000 into I1 minus I2. Same. Okay. Same thing I have written twice here. Okay. Okay, same whatever I have written above, same thing is repeated here. Okay, is equal to what? How many voltage sources are there in this mesh 1? Only one voltage source is there. Only one voltage source is there. Therefore, no need to write twice. Did I expand? I didn't expand it. I wanted to expand. That's it. The reason here I have written twice is I wanted to expand this 2000. So this is it. This is it. If you observe here, if there is any disturbance, you just message me, just mention in the chat box. So 47 into I1 plus 2000 into I1 minus I2 is equal to what? How many voltage drops are there? Only one, how many voltage sources are there? Only one voltage source. So since there is only one voltage source, okay, there is only one voltage source, write down that value. Okay. So algebraic sum of voltage drops is equal to the algebraic sum of the source voltages in the considered mesh or a closed path or a closed loop. Okay. So this is it. 2 voltage drops and 1 voltage source. This is 1 voltage drop. This is another voltage drop. This is 1 voltage source value. That's it. Now you just expand it. 47 I1 plus 2000. Just multiply it here. 2000 I1 minus 2000 I2 is equal to 30. And 47 I1 plus 2000 I1. You just add it. You will get 2000. 47 I1. Okay. So here. What is it? Is it minus? Yeah, it's minus. I have written plus here. I will just is minus. This is it. Okay, so 2047 I1 minus 2000 I2 is equal to 30. Consider it as equation 2, and this first equation consider it as equation 1. Okay, you can note it down while I'm explaining so that it may be useful to you. Okay, now this is it. This is our KVL equation for mesh 1. Let us apply KVL to mesh 2. Let us apply KVL to mesh 2. So if you apply KVL to mesh 2, just look at the mesh 2. This is our mesh 2, isn't it? This is our mesh 2. I'll just expand it. This is our mesh 2. In this mesh 2, what are all the elements that are available? R2, R3, R4. Is there any voltage source within this mesh 2? There is no voltage source. Okay. There is no voltage source in mesh 2. Only resistors are there. How many resistors? R2, R3 and R4. So since only resistors are there, there will be voltage drops within this loop. So how many voltage drops will be there? Voltage drop across R2, voltage drop across R3 and voltage drop across R4. Okay, voltage drop across R2, voltage drop across R3 and voltage drop across R4. Only 4 voltage drops will be there. Okay, I'm sorry, only 3 voltage drops will be there, not 4. So R2, R3 and R4. So what is the voltage drop across R3? How much is the voltage drop? Voltage drop means voltage. Voltage is how much? I into R. What is I? I2 into R value is 500. So 500 into I2. Okay, this is the voltage drop. Next, what is the voltage drop across R4? Okay, how much is the voltage drop? V into I. What is? I'm sorry. I into R. So what is it? What is the voltage drop here? I value how much? I2. What is R value? 500. Okay, R value is 500. Therefore, 500 into I2. Okay, so I'm looking at the number of people watching. It's very few members are watching. It seems all others are busy. I'm the only one who don't have any other work, isn't it? Okay then. So this is it. Here, 3 resistors are there in mesh 2. 3 resistors are there. So voltage drop across R2 plus voltage drop across R3 plus voltage drop across R4. So now I have started with R3 voltage drop to write the equations. What is the voltage drop across R3? I into R. What is I value? I2 into 500. 500 into I2 I have written here. Similarly, what is the voltage drop across R4? I into R. R value is 500. Current is I2. So 500 into I2. Okay. So voltage drop across R3 is 500 into I2. Next, voltage drop across R4 is 500 into I2 plus 2000 into same which we have written same similar to previous KVL equation for mesh 1. Similarly here also, if you observe, current direction I2 is upward, and in this loop current direction I1 is downward. So one is upward, another one is downward. One is upward, another is downward. Therefore, difference of I1 and I2. Since we are in mesh 2 now, that's why I2 minus I1. You must write I2 minus I1. Differential current will flow through resistor of 2000 ohms. Okay. So now what is the there is no voltage source. The algebraic sum of all the voltage drops is equal to 0. There is no voltage source, so we need not bother about it. So what is the KVL equation for mesh 2? 500 into I2. This is it. Next, 500 into I2. Okay, 500 into I2 plus 500 into I2 plus 2000 into I2 minus I1 equal to 0. This is our equation. Okay, now expand it. 500 plus 500, 2000. I'm sorry, 500 plus 5000, 500, 1000 I2, 1000 into 500 plus 500. So you just add these two, you will get 1000 I2. And here I have kept it as it is, 2000 I2 minus I1. And later, what did I do? I might have expanded this. I didn't do that. It's okay. So what I have to do is, so just 1000 I2 plus 2000 I2 minus I1 is there. So 2000 I2 minus 2000 I1. I have just expanded the above equation. And what you can do later is you just add the common terms. So I have added 1000 I2 and 2000 I2. I have got 3000 I2 minus 2000 I1 equal to 0. Okay. So I want to write I1 term first and I2 term later. That's what I have written in the next equation. Minus 2000 I1 plus 3000 I2. I took minus common in this equation. So I have got 2000 I1 minus 3000 I2 equal to 0. Consider this as equation 4 and consider this first equation as equation 3. Okay, I hope you have understood. If you have any doubt, anyone, if you have any doubt, you can ask. So these are the KVL equations for mesh 1 and mesh 2. So I thought if circuit is shown besides to the equations, it will be easy for you to follow. It will be easy for you to follow. So that's why I just kept circuit here. So these are the equations without circuit. So you just go through it if you want. They are very easy. Okay, they are very easy to write it down. If you know the concept, you will not bother about the number of terms that are available, how many lines of equations are there and all. If you know the concept, that is more than sufficient. Now we have now we have equation 2 and equation 4. Okay. So we have unknown variables. I1 and I2 are unknown variables are there. So now using a scientific calculator, okay, using a scientific calculator, you people can determine I1 and I2. Now you people solve it. Okay, whoever is attending the class, this class, okay, this online lecture along with the scientific calculator, you can calculate it and you can just mention in the chat box the answers for I1 and I2. So till now, if you are unable to follow, you just wherever you are stuck, whether you are able to understand the how to write the equations and all, if you are whether you are able to understand or not, you can mention in the chat box so that I will able to know. And if you want, I will repeat the concept once again. So anyhow, I have been explaining as slowly as possible. Using scientific calculator, determine I1 and I2 and just post it in the chat box. So in the comment section, someone has mentioned, could you explain how Kirchhoff's voltage law applies to non-ideal circuits where elements like capacitors or inductors are present? Okay. So you can apply Kirchhoff's voltage law for these elements such as capacitor or inductor. Similar to that we do for the purely resistive circuits. The only difference is that here we need to consider the voltage across them in terms of their impedance, okay, while writing the equations. Okay, so if we are able to consider, if we are able to write the equations in terms of the impedance, that is voltage equations to verify Kirchhoff's voltage law, then you can apply it. That's it. I don't know whether that person is still available in the channel or not. Someone has mentioned. So now, if I didn't receive any answer, it's okay. So the answer, if you solve using a scientific calculator, you can get I1 value as 0.0415 amperes and I2 value as I2 value as 0.0274 amperes. Okay, this is it. So if you want, you can convert this I1 current, which is in amperes, into milliamperes. So if you want to convert, I can write with my this cursor. What I am going to do is, I will take a text. Yeah, here it is. So simply what you can do is, you just take I1. Okay, I1 is equal to, you just divide 0.0415 by 1000. Okay, you just divide it by 1000. You will get how much? 41.5 milliamperes. Okay, so I1 current in terms of milliamperes. Okay, I1 current in terms of milliamperes is 41.5 milliamperes. Similarly, I2 current, if you want to determine I2 current in terms of milliamperes, this is in amperes, isn't it? So the milliampere value is 0.0274 divided by 1000. You will get 27.4 milliamperes. I2 current is 27.4 milliamperes. Okay. So I have written in amperes. If you want, you can write it down in milliamperes form. That's it. We have I1 and I2 current. We can determine voltage across all the elements in the given circuit. I'll copy the circuit so that it will be more easy for you to understand. This is our circuit. So now we have I1 and I2 current. So let us determine voltage across 47 ohms resistor by Ohm's law. Okay, apply Ohm's law. V is equal to I into R. That's it, isn't it? By Ohm's law. So what is the voltage across 47 ohms? It is I1 into R1. Okay. So what is R1? 47 ohms. What is I1? I1 is 0.0415. Okay, I1 is 0.0415 amperes. I didn't consider in milliamperes. I have considered in amperes. Okay. Where is my cursor? Here it is. 0.0415 into 47, that is 1.95 volts. Okay, it is 1.9 volts. 1.9 volts. Okay, so I will just respond to the person who just mentioned something. Is there any option to reply here? No. I have explained it. So if whoever has asked this question related to non-ideal circuit elements, did you listen to me or not? You just mentioned so that I don't know whether I have to type it in the chat box or whatever I'm explaining. Are you listening to me or not? So whatever. So let us continue now. So voltage across means voltage drop across this R1 is how much? I1 into R1. I1 is 0.0415 in the from the above equation into 47. You just solve it. You have got voltage across R1 as 1.95 volts. This is the voltage drop across R1. Now let us see the voltage drop across 500 ohms resistor by Ohm's law. That is across R3 as well as R4. The resistance R3 and R4 are same. Okay, resistance R3 and R4 are same. So since R3 and R4 are same, therefore even if you determine voltage drop across one resistor, that is more than sufficient because both the resistors are same. So what is the current flowing through R3, I2, and current flowing through R4 is also I2. So no need to calculate twice, but I have calculated here. So voltage across 500 ohms is I2 into R3, I2 into 500, R3 is 500. So what is I2 value? 0.0274, that is okay, into 500. So if you solve it, you will get 13.7. 13.7, you can leave it as it is, or approximate value you can write. I have written for 14 volts. No need to write 14, you can leave it 13.7. Okay, not 37, sorry. 13.7 volts. Okay, 13.7 volts, or if you want, you just round it to 14 volts. This is it. It's very easy. Just go through it. If you want, you just note it down in your notes. Okay, let us proceed further. Okay, then. Now, same equation. Let us determine voltage across R4. R4, how much resistance? 500. What is the current? R2. Same, whatever I have written earlier, same thing. I have just copied it. I didn't even type it here. Why? Because it is same, isn't it? So, what is voltage across 500 ohms? I2 into R4. I2 into R4 is 500. I2 value is how much? 0.0274 into 500. So, the voltage across 500 ohms is, that is voltage across R4 is 13.7 volts, which is approximately 14 volts. Okay. Now, what is the voltage across 2000 ohms? This is 2000 ohms. So, what is the voltage across 2000 ohms? Voltage across 2000 ohms is how much? Differential current. Okay, I1 minus I2 or I2 minus I1. You can take anything. Any means you can consider any equation. I1 minus I2 or I2 minus I1 into R2. Okay, so I have written, instead of writing minus, I have written differential symbol here. So you can write minus also. No need to write differential symbol. I have written minus symbol here. Sorry, differential symbol. No need to write differential symbol. You can write minus. So what is I1? I have written I1 minus I2 here. So I1 value is 0.0415 and I2 value is 0.0274. So just take the difference. You will get 0.0141 into, what is it? 2000. So just multiply it. You will get 28.2. I have just rounded it to 28 volts. Okay. So this is the voltage drop across R2. So we have determined the voltage drop across all the resistors. Okay, total how many resistors are there in the given circuit? Can anyone mention? In the chat box, how many resistors are there? How many? 1, 2, 3 and 4. I have written here R1, R2, R3, R4. Total 4 resistors are there. And we have determined the voltage drop across each and every resistor. Okay. Now let us verify Kirchhoff's voltage law theoretically. Okay. So that's why in the next slide I have mentioned. Next slide I have mentioned theoretical proof. Okay. So we have done calculations till now. There we have determined the voltage drop across all the elements. Now let us go for theoretical proof. Okay. So let us consider equation 1. Let us consider equation 1. What is equation 1? This is equation 1. 47 I1 plus 2000 I1 minus I2 equal to 30. That is equation 1. Okay. So 47 I1 plus 2000 I1 minus I2 equal to 30 is equation 1. Now substitute 516. What is 516? 516 is the current values. I1 value and I2 value. Substitute I1 and I2 in equation 1. Okay, instead of writing this 516, I didn't like this 516. Okay, substitute I1 and I2. Okay, substitute current values I1 and I2 in equation 1. So substitute I1 and I2. What is I1? 0.045. So 47 into 0.0415, sorry, plus 2000 into I1 value 0.0415 minus I2 value 0.0274 equal to 30. Okay, so you just solve it. So 47 into 0.0415 is 1.9, and 2000 into just subtract these two, you will get 0.014. Okay, so you may get more digits. I have not considered here. You may get more than, means after point you may get 4-5 digits. I have considered only 3 digits here, 0.014 I have considered. Okay, so here just solve this equation. So 1.9 plus 2000 into 0.014, and 2000 into 0.014 I have got 28. So 1.9 plus 28, you simplify it, you will get 29.9 equal to 30. So 29.9, it is not exactly equal, but approximately 29.9 means it is 30. So the what are these voltage drops in the given circuit are equal to the algebraic sum of voltage source voltages. Source voltage is 30. Voltage drop algebraic sum of voltage drop values is 30, means 29.9. So hence KVL is verified in the given loop or mesh 1. Okay, so algebraic sum of all voltage sources is equal to what? Algebraic sum of voltage drops in the closed path. Hence KVL is verified in mesh 1. Okay, so this is it. You can have a glance for a second on this slide. there is any issue, you just mention in the chat box so that I can go through it. I will try to rectify that issue. That's it. Now let us go. Let us try to verify KVL in mesh 2. Okay. Now here we have to verify KVL in mesh 2. So let us substitute I1 and I2 in equation 3. So what is our equation C? Let us go back and let us see what is our equation 3. So equation 3 is 500 into I2 plus 500 into I2. So plus 2000 into I2 minus I1 equal to 0. Okay, this equation we wrote directly from the mesh. Okay, applying KVL in mesh 2. Okay, so why did I put a bracket here? Okay, now let us go to our theoretical proof here. Now substitute what? Substitute currents I1 and I2 in equation 3. So 500 into I2 value is how much? 0.0274 plus 500 into I2 is 0.0274 plus 2000 into I2 is 0.0274 minus I1 value is 0.0415 equal to 0. Okay, you just solve it. 500 into 0.0274, you will get 13.7. 500 into 0.0274, you will get 13.7 plus 2000 into, okay, 2000 into 0.0274 minus 0.0415. So you just solve it. What do you get? 2000 into minus 0.0141. So minus, you just take it out. So 13.7, 13.7, I have rounded them to 14, 14. So 14 plus 14, this minus you just take it out. So minus 2000 into 0.0141. So you multiply 2000 into 0.0141, you will get 28.2. So 14 plus 14, 28 minus 28.2, I have rounded it to nearby value, that is 28. So 28 minus 28, you will get 0. So the algebraic sum of voltage drops is equal to 0. Okay, so algebraic sum of voltage drops in a closed path is equal to 0. So hence KVL is verified in mesh 2. Just have a glance on this slide. This is how KVL is verified theoretically. For the experiment which I have shown you how to verify KVL practically, for that this is the theoretical explanation. You just go through that video and go through this video also later. You can compare those two. Okay, both theoretical and practical values, you can compare them. I hope you have understood KVL. If you need more clarification, you just mention. Whoever is attending this class, just press the like button so that this video can reach to many more people who are in need of. Okay, those who are unable to understand KVL. Okay, so those people can go through this video. So if you click on the like button, what will happen is this video will be sent to many more people. So depending on number of likes, more viewers can watch the video. So till now, I hope you have understood how to verify Kirchhoff's voltage law theoretically. Okay, now let us verify Kirchhoff's current law theoretically. Same circuit. Okay, even in the practically verified circuit. If you remember, if you have seen that video, in that video you can see I have taken the same circuit to verify Kirchhoff's voltage law and Kirchhoff's current law practically. So I have taken the same circuit here once again. So if you observe here, okay, if you observe here, total how many nodes are there? Actually here total 2 nodes are there. You just observe. I will take a pen. So here to verify Kirchhoff's current law, you must always consider branch currents. To verify Kirchhoff's voltage law, we have considered loop currents. Okay, you can even verify Kirchhoff's voltage law by considering branch currents also. But it is more easier to verify Kirchhoff's voltage law using loop currents. That's why I have followed the loop method. So here you just observe. This is the only voltage source that is available in the circuit. Given circuit, there is only one voltage source. So from positive terminal, current will come out. It will flow like this. It will flow like this. It will flow like this. You can see there is a junction here. At this junction, what will happen? Current will divide. So the junction where current divides, that is, you can call it as a node. Yeah, you can call it as a node. Okay. So let us assume some voltage to this node. Okay, so node voltage V. Now this current, it will flow like this. It will flow like this. Sorry. It will flow like this. And so on. It will flow like this. This current, it will flow through this element 2000 ohms. These two currents, they will meet each other. What is happening? Okay. What is happening here? Current coming from this source. Current coming from this source. Let us assume the current coming from the source is current that is coming out of this source is some I1 current. I want to write I1 here, but I1 current. Now here current is divided at this node V. Current is divided into two currents, that is I2 and I3. Okay. So this I3 current is flowing like this, it is flowing like this, it is flowing like this. What is happening here? This I3 current. This is I3 current. What is this current? This is I2 current. So I3 and I2 currents. Here I1 is dividing into I2 and I3. What is happening? I2 and I3 are adding up here and they will add up and I1 current will flow like this and it will return back to the negative terminal of your voltage source wherever it has started. Okay. Oh, so someone has mentioned 4 nodes. Okay, so here I am going to consider wherever current divides. Okay, wherever current is dividing or adding up, I am considering only those nodes. I am not considering any other node here. You can consider, so you can consider this as one node, this as another node, this as another node. You can consider. Okay, the terminals of the resistive branches. Okay, each terminal of the resistive branch, you can consider that as a node. Okay, but according to me, wherever current divides, wherever current meets, okay, that junction I am considering it as node. That's why based on what I'm explaining, okay, so you can consider this as a node. Two branches, I can say the source. This is source branch, isn't it? 30 volt source branch. This is 47 ohms branch. These two branches are meeting at a node. 47 ohms and 30 volts are meeting at a node. So wherever two branches meet, it is a node. It is called as a node. Okay. So you can call it as a node. Wherever branches are meeting, you can call them as nodes. Okay. So according to whoever has mentioned there, actually 4 nodes. Yeah, you can consider. But I want to make this more simpler for the students whoever are listening to this lecture. So they will be, it will be easy for them to understand. If I say 4 nodes, and if I say at some junction, means at junctions current will divide. Here what will happen? Even though there is a node here between 47 and 30 volts, the current will not divide here. Same current will flow. I1 current is coming out of the source. I will write that current here. Okay. I1 current is coming out of this source. It won't divide here, isn't it? Why to call it as a node? Of course it is a node. I won't say it is not a node. It is a node. But to make this concept more simple and easy to understand, I have considered only those points as nodes or junction where current divides. That's it, nothing else. So you can consider this as a junction or a node. This is also a node. This is also a node. This is also a node. So someone has mentioned in the chat box there are 4 nodes. Okay. So there is no element here. So no need to consider this as a node. Okay. So I can't erase it now again and I can write it down. So what I can do is I have one more circuit. I have one more circuit here. So see, this is one node according to whoever has mentioned in the chat box. For them I am telling these are the wherever I am drawing the circles. These are the 4 nodes. Okay, you can call them as nodes. Why? Because two elements wherever they meet, that point you call it as a junction or node. Yeah, of course. Okay, you can call it as node. So according to that person, there are 4 nodes here, but I am going to consider here, to make this concept more simple, I am considering only those nodes where current is dividing. Okay, as I'm talking only about that, nothing else. Okay. So here current is not dividing. See, 30 from 30 source voltage, I1 current comes out from this positive terminal. Same current flows through 47 ohms. Of course, there is a node here. I am not mentioning it as a node. Okay. Okay. So wherever two elements meet, it is a node. That's it. So no need to confuse. So I have considered only those terminals as nodes or junction wherever current is dividing or current is adding up. So I have considered only this terminal and this terminal as nodes. Only 2 nodes I am considering here. Okay, that's it. I hope I have given enough clarification for the person whoever has mentioned as 4 nodes. Okay. Now, so here what is happening? I1, I2 and I3 currents are adding up here. Okay, at this node. So this node, you call it as a reference node. What do you call it as? Reference node. And voltage at the reference node is always 0. Okay. Voltage at the reference node is always 0. Okay. Voltage at the reference node is always 0. So, okay. So, of course, there are 4 nodes in this circuit, but I have considered only those nodes wherever current is dividing or adding up. Okay. So, there is one node V and another node of 0 volts. That node is known as reference node. So, you can see here in this diagram, you can see node voltage V and the node voltage, reference node voltage is 0 volts. Okay. So, what are all the branch currents that are there? I1, I2 and I3 branch currents. Now one more thing. So current flows through 47 ohms, 500 ohms, 500 ohms and 2000 ohms. Now in which direction current flows through these elements? You can assume your own directions. Okay. You do not follow the supply direction. Of course, if you see here, positive terminal is upward. This is my positive terminal of 30 volts. Therefore, current should flow. I1 current should start to flow from 30 to 4 V node voltage, no, okay, so towards the node, sorry, not voltage. So 30, from 30 volts, I1 current should start to flow towards the node. Here current should divide. So the actual current direction in this circuit is at this node V. Okay, so this lecture is uh, for those who are unable to, who want concepts to be more simple and easy to understand. For them, I have decided to deliver the lecture. Okay, so if we dig into the concept, there are many things that are to be discussed in detail, but I am not going in detail here. Okay, so whoever knows already the concept and whoever are listening to the class, so I think for them it is of no use because I'm not going in depth into the concept. So I'm discussing in the simpler and easiest way possible so that those who are studying BTech, those can easily follow the lecture. So for them it will be easy to solve the means theoretically solve the circuit. Okay. So I'm going to erase. So this is the actual current direction. Current will enter at this node V. I1 current will enter. I2 and I3 current will leave node V. But you need not follow that. Okay, though there is no need to follow the current direction based on the sources that are available. You can assume any current direction. Okay. So what I have done is, if you observe carefully, I have assumed current at node V. Okay, there how many branches are meeting at node V? Three branches are there, isn't it? Three branches are there. 1, 2, and 3. Total 3 branches are there. Yeah, whoever have written some equation, voltage equation you have written, it's okay, it's right. It is for KVL. KVL equation. Somebody has written. That is okay. That equation is correct. Equation which you have written is correct. Okay. Uh, equation. It is correct. That equation is correct, but what you have done is you have written all the so I'm replying to the text message here. So you have considered all the source voltage terms and the voltage drops on one side, isn't it? You have written all the terms on one side and equated it to 0. That is also correct. But in my slide, okay, in my PPT, what I have written is I have written all the voltage drops on one side. Okay, and all the source voltage terms on the other side. So what you have written, it is also correct. Okay. So in between, someone is texting messages for them. I'm replying it. Okay. So now here, so of course there are 4 nodes here because wherever 2 branches meet, that is a node. But I have considered only major 2 nodes wherever here current is dividing. Here current is adding up. I have considered only these 2 nodes. So to make this concept more simple and easy to understand. Now let us consider node V. Okay, this is our node V and this is reference node. Okay, reference node voltage is 0. I have assumed here all the currents leaving. You can assume all the currents entering a node. You can assume all the currents leaving the node, or you can assume some of the currents entering and some of the currents leaving the node. It's your wish. Okay, you can assume anything that you want. Anything means you can assume any current direction at the node. Okay, you can assume any current direction to enter the node. You can assume any current direction to leave the node. You can assume all the currents to enter the node, or you can assume all the currents to leave the node. Okay, so it doesn't matter, it's our wish. Okay, but I have assumed here all the currents are, I have assumed as if all the currents are leaving. I see I1 current is away from node, I2 current is away from node, I3 current is also away from the node. Okay, so it's our wish. But if you carefully observe here, I'm going to take some other ink. Okay, so if you carefully observe, this is my positive terminal of this. There is only one source available here. Only one source is there, isn't it? There is only one source available here. So definitely current in the circuit is only due to 30 volts. Current in the circuit is only due to this 30 volts voltage source, and definitely this I1 current, actual current direction should be from 30 volts towards the node V. Current direction, the blue color arrow mark which I have drawn here, that is the actual current direction. Okay, that is the actual current direction. So definitely when I determine the I1 value, that will be a negative value. It is opposite, isn't it? The direction which I have assumed here, I1 direction which I have assumed here, is opposite the actual current direction flow. So definitely whatever I1 value that I am going to get, it will be negative. Okay, negative value I will get. Let us see, let us solve and check whether I am going to get negative current or positive current. Let us see that. But according to this circuit, okay, according to this circuit, based on the location of the source, you can see that I1 direction should be in clockwise, I can say, but I have drawn in anti-clockwise direction. Just these two are opposite to each other. Okay, so see, even though I know that current will flow from 30 volts towards the node V, I know that, but I have assumed in the opposite direction. Okay, so you can assume anything, it doesn't matter. Only the thing is, if you have assumed the current direction opposite to the actual current direction flow, actual direction in which the current will flow in the given circuit, then what will happen is you will get negative current value. So if you get negative current values, then you can simply say that, you can write a statement and you can mention that actual current direction is opposite to the assumed direction of the current in the given circuit. Okay, so my assumed current directions are, all the currents are leaving the node. I think I'm explaining a lot. Okay, even a small term I'm taking much longer time. So now I'm going to copy this circuit. Okay, I'll just keep it. Now this is my circuit. Okay, this is my circuit. Now here I just copied it, but those arrow marks, they didn't come. Okay, leave it, it doesn't matter. Now what did I assume? I have assumed all the currents are leaving, means all the current directions are same. They are leaving means they are in same direction. All the currents are entering means they are in same direction. Some currents are entering, some currents are leaving means on leaving currents are in same direction, or entering currents are in opposite direction. That's it. So here I have assumed I1, I2 and I3 are leaving. Therefore, the algebraic sum of currents at this node V, according to KCL, it should be equal to 0. Therefore, I1 plus I2 plus I3 is equal to 0. Okay, I1 plus I2 plus I3 is equal to 0 here. Okay, so I1 plus I2 plus I3 is 0. Therefore, now let us apply Ohm's law and write down the current equation. I1 equation, I2 equation, I3 equation. What is I1? What is I1 current? I1 is what? See, current is, according to me, according to the assumed direction, I have assumed current is leaving V and moving towards 30, isn't it? That's what I have assumed. So always current flows from higher potential terminal to lower potential terminal. Okay, current always flows from higher potential terminal to lower potential terminal. I is equal to what? According to Ohm's law, I is equal to V by R. Okay, so I want I1 current. I1 current flows through R. What is R value? 47. So I1 equal to some V by 47. What is V here? potential difference across 47 ohms. What is the potential difference? So here on one end side of 47, V is there. On the other end, what is there? 30 is there. Okay. On one side of this 47, okay, just I'll just expand it. On one end side, V is there. On the other hand side, what is there? 30 is there. Okay. So, what is I? V minus 30. Why V minus 30? Because current direction is from V to 30. Okay. Current actual direction is should be from 30 to V. But since I have assumed in the opposite direction, so it is V minus 30 because current always flows from higher potential to lower potential. So, according to me, whatever I assumed current direction that I have considered here, according to me, okay, V minus 30 is the voltage across 47 ohms divided by 47. Okay, so what is I1? What is I1? I1 is what? V minus 30. V minus 30 by 47. If anyone is unable to follow or unable to understand, you just ask. You just mention in the chat box so that I will reply. Okay. So this is I1. What about I2? I2 current is flowing from V node V to reference node. Current flows from node V to reference node. So what is I? V by R. What is V here? Potential difference across 2000 ohms. What is the potential difference? Current has started from V ending at 0 volts. So V minus 0. See, I have written V minus 0 divided by how much? 2000. So what is I2 current? I2 current. Okay, my cursor won't listen to me. What is I2 current? It is I can't use this pen. I will take the pointer. What is I2 current? V minus 0. V minus 0 by 2000. Okay. So why V minus 0? So current I2 is started from V ending at 0 volts. Okay. So it is in this branch. So potential difference across the element. Okay. So which element? 2000 ohms. So V minus 0 by 2000. Okay. So V minus 0 means what? V by 2000. Okay. So what is I2? V by 2000. What is I1? V minus 30 by 47. Okay. So now let us determine I3. So I3 current. So same circuit it is here. So to determine I3. So I3 is flowing from V in this direction. I3 is flowing from where? It has started from V and it will travel up to here. Okay, it is flowing like this. Okay. My cursor won't listen to me. That's the main issue that I have. That is the only issue actually I have. It's a very sensitive cursor. This is it. This is the direction in which current is flowing. Which current? I3 current. Okay. I3 current is flowing like this. It has started from V, ended at 0, isn't it? So, what is the voltage? What is the voltage? Means the potential difference across this branch. Across this branch, potential difference is V minus 0 divided by how much resistance? This I3 current flows through 500 ohms and this 500 ohms. So, what is it? V minus 0 divided by 500 plus 500. Okay. So, always while writing current equation, you just consider the terminal from where current has started and consider the terminal where current ends. Okay. The terminal from where current has started. Explain once again. Someone has mentioned to explain once again. I will start explaining the KCL. Okay, I will start this once again. So see here, this is our voltage source. How many elements are there here? Total 4 elements. Okay. R1, R2, R3. I will take laser. Source voltage R1, R2, R3 and R4. So according to someone who have mentioned that in the chat box, they have mentioned there are 4 nodes. Of course, there are 4 nodes. This is a voltage source. What are all the terminals of this voltage source? These two are the terminals of this source. Okay. What are all the terminals of this resistor? 47 ohms resistor. This is one terminal. This is one terminal. So wherever two branches meet, source branch, the source branch and 47 ohms branch meet, that is a node, of course. And this is one node where the 3 branches are meeting. Okay, the three branches are meeting. This branch is meeting with this branch at this node. So that is one node. And this branch is meeting with this source and this resistor at this node. This is another node. Total 4 nodes according to someone, whoever have texted in the chat box. Okay, but okay, so but I'm not considering all the nodes here. I'm going to consider only those nodes where current divides or current adds up. So current starts to flow from 30 volts towards this source voltage. I'm sorry, I'm speaking rubbish. Okay, now so current starts from this 30 volts. Let us assume I1 current. It flows like this. Okay, and at this junction, what is happening? Current will divide. Current will divide. So actually what happened here is earlier I just saved this slide. That's why those arrow marks, they didn't go away. So current will start from positive terminal. It will flow like this. After coming to this junction, what will happen? Current will divide. Okay. So let us assume the current that has started from the source is some I1 current. It flows like this. At this junction, current will divide into I2 into and I3. Okay. Current will divide into I2 and I3 current. Okay. So since current is dividing, consider this as a junction or a node and consider some node voltage at this node. So let us assume voltage at this node is some V. Okay. So now this current will flow through 500 ohms and same current will flow through 500 ohms. Of course, 500 ohms and 500 ohms are meeting at a point, that is, you can call it as a junction, but current call it as a node. But since current is not dividing, I am not considering it as a node here. So 500 I3 current flows through 500 and this 500 and it will return back to this point. Okay. And this I2 current has started from this node. It will flow through 2000 ohms and it will meet at this point. So this I2 current and I3 current, they are meeting at this point. They will add up. Here they divided, isn't it? I1 divided into I2 and I3 at this junction. At this junction, I2 and I3 will add up and I1 current once again will flow through this branch towards this source, negative terminal. Okay. So there, how many currents are there? Branch currents are there in this given circuit. Only 3 branch currents are there. I1, I2 and I3. So total 3 branch currents. Someone asked me to explain once again. That's why I'm repeating. Okay. So total 3 currents, branch currents will be there in this given circuit. Okay. So one branch current is, which starts from 30 volts. It will flow through 47 ohms. And after reaching this node V, that I1 current, which flows through 47 ohms, will divide into I2 and I3. This I3 current, I2 current will meet at this junction and they will add up, and I1 current, when they add up, I2 plus I3 is nothing but I1. So I1 current will flow, will return back to the negative terminal of the 30 volts. Okay. So the junction where both the currents are meeting is the reference node, and the reference node voltage will be always 0. Reference node voltage will be always 0. Okay. So always, to make it more simple, don't confuse, don't think much. You just locate the source. Okay. Wherever sources are there, voltage source or current source, wherever source is there, just locate it. Assume current with your with some pencil. You just check from positive terminal current will come out. From positive terminal current, it will flow like this. And after coming to this junction, what will happen? Current will divide. Therefore, This is a node, consider it as a node and give some notation, some V1, V2, V3. You can assume any notation. I have assumed only V here. And you just see current will flow like this. After dividing here, what will happen? Current will flow like this. Okay, and this current will flow like this. It will meet at this junction and it will return back to the negative terminal. Okay, so consider this node or the junction as reference node. Okay, so here in general, okay, of course there are four nodes, but in general there are only two nodes. I am considering only two nodes here, wherever current divides or wherever current adds. Okay, I hope I was able to explain. I hope you are able to follow me. I hope I have not confused you people. So if still you are unable to follow, you just mention the chat box. Okay, so that I will see. I will try my best to explain in some other pattern. Okay, this is it. Now let us consider this circuit. Already it is there here. So here I have assumed, what did I assume here? All the currents are, I didn't mention that, isn't it? So here this is my circuit. So even though I know that current will start to flow from 30 volts voltage source towards this junction V, okay, or node V, but I have assumed I1 current in the opposite direction. So as I have already mentioned, you can assume the current direction in the given circuit at the junctions or nodes on your own wish. You can assume all the currents entering the junction. You can assume all the currents leaving the junction. You can assume some of the currents entering and some of the currents leaving. Here, how many branches are there total? You can categorize all the branches into only three branches are there here. Okay. So this is one branch. So this is one branch. This is another branch. This is the third branch. Okay. So total three branches are there. I'll take a laser. See, this is one branch. This is another branch. This is another branch. Total three branches are there. So since there are only three branches here, okay, there are three branches. So three branch currents will be there. And you can assume all these three branch currents either entering the node V, okay, either entering the node V, either leaving the node V, okay, or you can assume I1 current entering, I2 and I3 current leaving, your wish. But I have assumed here all the currents are leaving the node V. Okay, you can see leaving, they are leaving. This red color arrow marks are away from node V, means they are leaving node V. Okay, but actual current direction is what? From 30 volts to V. Current blue color represents the actual current direction, but I have assumed in the opposite direction. So now let us write down the KCL equations. Okay, so according to KCL at node 1, okay, apply KCL at node 1. So if you apply KCL at node 1, or I'm sorry, node V, I have assumed here node V. So if you apply KCL at node V, what will have, since you have assumed all the currents are leaving, therefore the algebraic sum of all the currents is equal to 0. Even if you assume all the currents entering, the algebraic sum of all the currents should be equal to 0. Okay, so if you assume I1 current is entering, if you assume I1 current is entering V, I2 and I3 are leaving, then you can write I1 is equal to I2 plus I3. Okay, I1 is equal to entering currents. Algebraic sum of entering current should be equal to algebraic sum of leaving currents. According to Kirchhoff's current law, algebraic sum of entering current should be equal to algebraic sum of leaving currents. So I1 should be equal to I2 and I3. So here we have assumed all the currents are leaving. So I1 plus I2 plus I3 is equal to 0. If you assume all the currents are entering node V, just opposite to this direction, then I1 plus I2 plus I3 will be equal to 0. Same equation you will get. Okay. Now, let us write down the current equations. Let us write down the current equations. So if you see here, How many currents are there? 3 branches as it. So since there are 3 branches, 3 branch currents will be there, I1, I2, I3. So what about I1? What is I1 value? I1 is, I is equal to what according to Ohm's law? V by R. What is R? I is flowing through 47 ohms. R value is 47. What is V? V by R. What is V? V is the potential difference across this resistor. Potential difference across this resistor is V. So what is the potential difference across this resistor? What is the voltage across this terminal? And voltage across the another terminal. Voltage across this terminal. Okay. Potential difference across the voltage difference across the terminals of that particular branch. So here if you see there is a 30 volts. Is there any element between this node and this 30 volts? There is no element. So this node voltage is 30. Okay. So node means meeting point of two branches is 30. So here what is the voltage? V. I don't know value. I don't know the node voltage value here. So it is V. So what about the potential difference across 47 ohms? Current direction is from what? From V to 30. Here current direction is this. From V to 30. Therefore, current direction is from V to 30. I am very much talented. I can't even draw an arrow mark. Okay, so current direction is from V to 30. Therefore, V minus 30 divided by 47. What is it? What is I1? V minus 30 divided by 47. Why V minus 30? Why V minus 30? Why? Because we have assumed current to travel from V to 30. Okay. Travel means current is flowing from V to 30. So current always flows from higher potential to lower potential. Okay. So that's it. Now let us determine I2 current. What is I2? I2 is the current flowing through 2000 ohms. So I2 current flows from, this is one of the terminal of 2000. Another terminal of 2000 is this. These are the two terminals of 2000. So I2 current flows from where? From V, from this junction V, from this junction V, from this junction V to reference node. Okay, so V minus 0. Potential difference is what? Voltage difference. Potential difference means voltage difference across the element. So potential difference is what? V minus 0 divided by 2000. So V minus 0 divided by 2000. V minus 0 means V. So I2 is what? V by 2000. So are you able to follow or not? Please mention. I have repeated the same thing twice. Okay. Let us go to the next slide. Now, if you observe here, now we have to determine the current flowing through through what? Through 500 ohms and 500 ohms. Okay, I3 current. I have to determine I3 current. This I3 current flows through what? It flows through this 500 ohms and this 500 ohms. So where did it start? What are the terminals of this branch? This 500 and this 500. I didn't consider these two as two branches. I have considered these two as a single branch. Of course, these two branches, these two elements, 500 ohms and 500 ohms are meeting at a point here. You can call it as a node, but I didn't consider them as two branches. Why? Because current is not dividing. I3 current flows through this 500 as well as this 500. Okay, so same current is flowing. So I am assuming as a single branch. Okay, this both 500s are connected to a single branch. I am assuming them as a single branch, not two branches. So what is the what are the terminals of this I3 current? It starts from this node. Terminals of these two branches, I can say. So this is one terminal and this is another terminal of this branch. So I3 current will start from here isn't it? I3 current will start from V and it will end at 0 volts. Okay, so it will start from V and it will end at 0 volts. Therefore, so what is the according to Ohm's law? Potential difference here is what? V minus 0. Okay, it is higher potential to lower potential. So V minus 0 divided by what is the resistance? 500 plus 500. Both are connected in series, isn't it? Current is not dividing means elements are connected in series. Okay, so if the current is not dividing, that means that elements are connected in series. Okay, so V minus 0 by 500 plus 500 is thousands. V minus 0 V. So what is I3? V by 1000. I3 is V by 1000. Now consider I1 equal to V minus 30 by 47 as equation 2. I2 equal to V by 2000 as equation 3. Okay, I1 equal to V minus 30 by 47, you consider it as equation 2. I2 equal to V by 2000, consider it as equation 3. And I3 equal to V by 1000, consider it as equation 4. Okay, total 3 equations. Okay, now substitute this 2, 3, 4 in which equation? I'm sorry. Substitute this 2, 3, 4 in equation 1. I1, I2 and I3. Just substitute in equation 1. I will remove this. Sorry, where is it? So this circuit, that circuit was to explain you how to write the equations. Now substitute 2, 3, 4 in equation 1. V minus 30 by 47 plus V by 2000 plus V by 1000 is equal to 0. So you just expand it. V by 47 minus 30 by 47 plus V by 2000 plus V by 1000 is equal to 0. Just I have expanded this. Okay. And you can send this 30 by 47 to the other side. So if you can do that. So I'm going to the next slide. So V by 47 plus V by 2000 plus V by 1000. I have sent that minus 30 by 47 to the right side. So it has become 30 by 47 equal to 30 by 47. You will get here, take V common and simplify this. You will get V into 0.027765. 30 by 47 is 0.63829. And so V is equal to this term 0.6382 divided by 0.02776. You just divide it, you will get V equal to 28.0243, approximately equal to 28 volts. So V is equal to what? Node voltage. Okay, the junction where the currents are dividing. Okay, the junction where currents are dividing is the 28 volts. So you just go through these equations. They are very simple and easy to write it down. Simply we have determined I1, I2, I3 equation, substituted in the first equation, that is I1 plus I2 plus I3 equal to 0, and we have simplified it and we have got the node voltage. Consider it as equation number 5. Now substitute this equation 5 in equation 2, 3 and 4. Okay, substitute equation 5 in equation 2 to determine I1 value. Okay, to determine what? To determine I1. Substitute 5 in equation 2. So I1 is what? V minus 30 by 47. V is what? 28. V is 28. 28 minus 30 by 47. You just simplify 28 minus 30 minus 2 by 47. You just solve it. You will get I1. You just see you have got a negative current. I1 you have got negative. Why did you get negative? Why? Because you have assumed the opposite direction to the actual current direction. Okay. So actual current direction was opposite to what I have assumed. Okay. So I have got negative current, I have left it as it is. I have got in amperes minus 0.042 amperes. So I want in milliamperes. I want current in milliamperes. So what did I do? I have divided it by 1000. So I have got minus 42 milliamperes. Okay. So minus 42 milliamperes. I1 current is minus 42 milliamperes. I1 is minus 42 milliamperes. It's simple. If you are noting it down, you just note it. I hope you are able to follow. Are you able to follow or not? You just mention in the chat box. It's good. Some of you are. It's good. Some of you are responding. Okay, it's good. That's how a class should be. There should be proper interaction between the staff and the people who are watching. Then only the class gets interesting. It should not be always one way. Okay, I hope you are able to follow. I1 current next. Consider it as equation number 6. And let us determine I2. What is I2? V by 2000. V is 28 by 2000. You will get I2 equal to 0.014 amperes. So see, you may get more number of digits after point. Okay, I have considered only 3 digits after point. So you may get more. You can write it down as it is if you get more values, or you can consider at least 3 digits after point. So I have considered only 3 digits. So it is in amperes. I2 is 0.014 amperes. I have converted it into milliamperes. So simply I divided it with 1000. So I think here I think something is wrong with my terms here. Uh, Here what I should do is 42 by 1000. Mhm. I'm not writing it properly, isn't it? This is it. Yeah, 42 by 1000 amperes. So is nothing but 42 milliamperes. This is it. Here also I should write 14 by 1000 amperes. That is nothing but 14 milliamperes. So 0.014 amperes. You can write it as 14 by 1000 amperes. 14 by 1000 it is nothing but 14 milliamperes. That's it. Okay. So earlier I wrote that milli unnecessarily in the. Okay, this is it. So this is my I2 and similarly I3. Similarly I3. So here what is I3 equation? I3 equal to V by 1000. So V is 28. 28 by 1000 is nothing but, instead of writing like, okay, 0.028. So I have once again I already got 28 by 1000. It's okay. So once again I have written back this second equation here in order to convert that amperes into milliamperes. That's it. So okay, we have got some equation 6, 7 and 8, I1, I2 and I3. Okay. So we have written I1, I2 and I3, seek equations. I1, I2 and I3, three equations we have got, equation 6, 7 and 8. So now let us substitute this 6, 7 and 8 in equation 1 to verify Kirchhoff's current law. So I have written all the equations here. You can see I1 was minus 42 milliamperes, I2 was 14 milliamperes, I3 was 28 milliamperes. Now let us go for theoretical proof from equation 1. What is equation 1? I1 plus I2 plus I3 equal to 0. Now substitute 6, 7, 8 in equation 1. We will get what? Minus 42 plus 14 plus 28 equal to 0. So 14 plus 28 is 42. Minus 40 plus 42 equal to 0. So 0 equal to 0. So here what is happening? The algebraic sum of all the currents meeting at a junction is equal to 0. Or algebraic sum of all currents meeting at a node equal to 0. Hence KCL is verified. This is a theoretical proof. So I have verified the Kirchhoff's current law. I hope you have understood Kirchhoff's voltage law and Kirchhoff's current law. I will discuss superposition theorem and I will conclude this. So I tried to explain as simpler possible way as possible. So I have made everything very simple. I have written each and every step to explain this concept. So I hope you are able to follow. Even if you are unable to follow, you can go through this video later on once again to know whether you are able to understand the concept or to understand more betterly. Okay. So I'm going for superposition theorem verification. So I'll start this. Next, theoretical calculation to verify superposition theorem for this given circuit. So if you remember, if you have gone through this um, practically verified superposition theorem video, which is available in my channel, this is the same circuit for which I have verified superposition theorem practically. Okay. So let us verify it theoretically. So this is the given circuit. This is the given circuit. So you can see here in this circuit, our voltage source is 30 volts. There are, of course, there is another voltage source. Superposition theorem is applicable for the circuit which has multiple sources. Okay. For the superposition theorem, you now to implement superposition theorem, there should be multiple sources in the given circuit. So multiple means more than one. So whenever you want to verify superposition theorem, you just check whether there are more than one source available in the given circuit or not. Okay, there are more than one sources available in the given circuit or not. If more than one source is there, then only you can implement superposition theorem to verify then only you can verify superposition theorem for the given circuit. So now if you observe in this circuit, there are two sources, 30 volt source, another voltage source, 30 volt source. Okay. So how many elements are there? Total means passive elements 3000 ohms, 500 ohms and 2000 ohms. Total 3 resistive elements are there and 2 voltage sources are there. So to verify superposition theorem, you can apply Kirchhoff's voltage law or current law, your wish. You can assume, you can implement any law to verify superposition theorem. But today I am going to use Kirchhoff's voltage law to verify superposition theorem. So, according to superposition theorem, uh, in any element in the given circuit, in 1000 ohms or 500 ohms or 2000 ohms, in any among these three elements, whatever current flows when both sources are present in the circuit across any element, that should be equal to the algebraic sum of the currents flowing through the same element when individual sources are present. Individual means when only this voltage source is there, this is removed. Whatever current flows through any of these elements must be, if you add that with the current flowing through the same element when this source is removed, when only this source is present. Okay, when you add those two current, that should be equal to the current flowing through any of these elements when both sources are present. Okay. So let us consider 500 ohms resistor. Let us calculate the current flowing through this 500 ohms resistor when both sources are present. Okay. So when this source and this source, both sources are present, current flowing through this 500 ohms. Okay, let us assume it as I. Okay. Now when this source is removed, current flowing through this 500 ohms when only this source is there, let us assume it as I dash. And current flowing through this 500 ohms when this source is removed and only this source is there, let us assume current flowing through this 500 ohms is I double dash. Then I should be equal to I dash plus I double dash. Okay. So till now whatever I spoke regarding superposition theorem, if you are unable to understand, it doesn't matter. I will explain it in detail in the further slides. Okay. So to verify superposition theorem, let us first of all consider, actually here total three cases will be there. One case is when all sources are present. Here only two sources are there. That's why there will be only three cases. If more than, it depends on number of cases will depend on number of sources. So first case is when all sources are there, and second case is when individual source is there. Third case, individual source. If more than two sources are there, number of cases will increase. Here only three cases will be there. When both sources are present, one case. When only this source is present, one case. When only this source is present, another case. Okay. So uh, let us consider when both sources are present. I didn't mention V1, V2. Okay. So I will just add V1 and V2 so that it will be more easy for you to understand. It will be more easy for you to understand. One second. So here two sources are there, V1 source and V2 source. So it will be more easy to understand if we mention V1 and V2. So that's why I have considered this. So I think again and again for each and every circuit I have to add. Now let us consider case 1 when both voltage sources V1 and V2 are acting in the given circuit. Okay, both sources are there, V1 and V2 sources are there. So, one second. So you can see, so earlier V1, V2 was not mentioned in here. So I thought it will be more clearer to explain with this notations. I didn't add earlier. I have added it. Okay. So here both sources V1 and V2 are acting in the given circuit. Okay, V1 and V2 are acting in the given circuit. Here okay then whatever. So some message is there, but okay, I have to complete this superposition theorem. That's why I'm not going to concentrate on that. So whatever. So here loop currents, I have assumed loop currents here, loop current I1 in mesh 1, loop current I2 in mesh 2. Okay, two sources are there, V1 and V2, mesh 1, mesh 2, and in mesh 1 loop current is I1, mesh 2 loop current is I2. Now loop current direction, I1 direction, I2 direction, your wish. You can assume both loop current directions clockwise, or you can assume both loop current directions anti-clockwise, or you can assume one loop current direction clockwise, another loop current direction anti-clockwise. So here what I have done is, simply simply depending on the sources. Okay, so I have just looked at the source. You can see positive terminal is upward. Here also positive terminal of this source is upward. Definitely current will flow in clockwise direction into the circuit because of this source, and current will flow and anti-clockwise direction because of this source. So that's why it's my wish. Okay, your wish. You can assume any direction for the current. Loop current direction can be any direction. So here I have assumed I1 current in clockwise, I2 current in anti-clockwise. Don't think much. If you think much, you will confuse more. So to just simply assume some direction, okay, you assume some current direction, okay, or you can follow the path of your sources, okay. So positive terminal is upwards, I have assumed in anti-clockwise. This positive terminal is upward, I have assumed in clockwise. That's it, nothing else. So I have assumed I1 in clockwise, I2 in anti-clockwise. Okay, so these are my loop currents of mesh 1 and mesh 2. Okay, so what is our first case? First case is both the sources are present. Now here what I'm going to do is I'm going to concentrate on this resistor 500 ohms. See, what is the current in 1000 ohms? I1 current. What is the current in 2000 ohms? I2 current. What about the current in 500 ohms? What is the current in 500 ohms? If you observe, I1 current is downward. What about I2 current? It is also downward. Both are in downward direction. That means both the currents are in same direction. Both the currents are same direction means sum of I1 and I2 will flow through 500 ohms. Okay, sum of I1 current and I2 current will flow through 500 ohms. Okay, since I1 current, I2 current both are in same direction, both are downwards. Therefore, sum of these two currents will flow through 500 ohms. Okay, now I want to verify superposition theorem for the current flowing through 500 ohms. Okay, for the current flowing through 500, you can consider any branch. You can consider either 1000 ohms or 2000 ohms or 500 ohms. I have considered the middle branch 500 ohms. So I want to verify superposition theorem by considering the current flowing through 500 ohms. Okay, so that is my main aim here. So that's why what I have done is I have assumed the current direction in 500 ohms. Let us assume I is the current flowing through 500 ohms. Okay, I is the current flowing through 500 ohms when both sources 30 volts, V1 and V2. Okay, and both sources V1 and V2 are present in the given circuit. Okay, here I want to I will write I. So simply I will write I here, that's it, nothing else. So I want to write I in time Romans. Just a second, it's over. I'll just this is it. This is my I. So I amperes of current is flowing through this 500 ohms when both sources V1 and V2 are present in the given circuit. Okay, so I amperes of current is flowing through this 500 ohms when V1 V2 are both are connected in the given circuit. Now let us apply this KVL in mesh 1. Let us apply KVL in mesh 1. Okay, so let us apply KVL in mesh 1. What is there in mesh 1? You just observe in mesh 1. 1 second. Nothing is there. Okay. So what is there in mesh 1? There is something. Yeah. Okay. Yeah. What are all the elements that are available in mesh 1? If you observe here, what is there in mesh 1? Voltage source V1 30 volts and two passive elements 1000 ohms and 500 ohms in mesh 1. Okay. Only total 3 elements are there. One source element, one active element and two passive elements. Active element is source voltage. Passive elements are 1000 ohms and 500 ohms. Total 3. Okay, total 3 elements are there. So uh, I want to apply KVL here. So the algebraic sum of voltage drops is equal to algebraic sum of the source voltages. So what is the voltage drop here across 1000 ohms? 1000 into I1. Okay, 1000 into I1 is the voltage drop across 1000 ohms. Similarly, what is the voltage drop across 500? As I already told you, the current direction, this is downward, this is downward. So both are in same direction. So 500 into I1 plus I2 is equal to, what is the voltage source value? 30 volts. Okay. So 1000 into I1 plus 500 into I1 plus I2 equal to 30. So you just expand this. Okay. So if you expand, you can expand. I can write one more equation here. It will be more easier to understand. No need, but I will write it. So it is 1000 into I1 plus 500 I1 plus 500 I2. So you just add these two, 1000 I1 plus 500 I1, you will get 1500 I1 plus 500 I2 equal to 30. Okay. So consider it as equation 1. Okay. Consider it as equation 1. Now let us go to mesh 2. Let us go to mesh 2. In mesh 2, what are all the elements that are available in mesh 2? How many elements are there? Total 3 elements in mesh 2, isn't it? I'll just expand this screen. So total 3 elements in mesh 2. How many? Source voltage V2, passive element, resistive element 2000 ohms, and another passive resistive element 500 ohms. Total 3 elements in mesh 2. So source voltage and 2 passive elements. So what voltage drops will be there across these 2 resistive elements? So what are all the voltage drops here? So voltage drops are 2000. 2000 what is the voltage drop? Resistance I into R. R value is 2000. What is I2? 2000 into I2 plus 500 into what? I1 plus I2, because current direction is downward, current direction is downward. Both current directions are downward. That's why. So 500 into I1 plus I2 equal to what? Source voltage. That is 30 volts. V2 equal to V2. You can write V2 instead of instead of this 30. It will be more clearer, isn't it? I'll just end the show, and instead of 30, I can write V2, isn't it? So somewhere V2 is there. So instead of V2, I can write V2. And see, to make it more clearer, because both voltages in mesh 1 as well as mesh 2, um, both the voltages are same, isn't it? 30 volts and 30 volts. That's why to make it more simple and to understand. So it's not, the cursor is not listening to me. I don't know why. Okay, whatever. So in mesh 2. So this is V2. So 2000 I2 plus 500 into I1 plus I2 equal to V2. So V2 value is 30. So I can write one more equation here, isn't it? So this is it. Yeah. So I have just expanded it. Here I can write 30. So simply I have expanded it. This is 500 I1 plus 2000 I2 plus 500 I2 is nothing but 2500 I2 is equal to 30. So we have got two equations. I will delete this circuit now. So we have got two equations, equation 1 and equation 2. So solve equation 1 and 2 using your calculator. No need to do it manually. So if you have scientific calculator, directly you can substitute these equations in that scientific calculator and you will get the values. So values are I1 equal to 0.0171 amperes and I2 is 0.0086 amperes. Just go through this slide. So I hope you have gone through this slide. So I1 and I2. Now, so what is the current in 500 ohms? I1 plus I2. So what is 500 ohms current? We have assumed in the circuit, we have assumed that current as I. So we have assumed the current as I here. In this slide, you can see I. So what is I equal to I1 plus I2? I1 value 0.0171 plus 0.086. You just add it, you will get I equal to 0.0. It is 0.27. Huh? Okay. Okay then. So 0.0275, 257, sorry. 0.0257 amperes. It is amperes. Amperes current you will get. So you can convert that into milliamperes. Okay. So 25.7 milliamperes you will get. Okay. So this is it. This is our I value. When both sources are present, this is the current flowing in 500 ohms resistor. Now let us go to case 2. So in case 2, when only source voltage V1 is acting in the given circuit. So what did I do? I didn't short circuit this. Okay, it's okay. I will do it now. So this is it. Only V1 is acting in the given circuit and current through 500 ohms. Let us assume it as some I dash is the current through 500 ohms. So earlier we have assumed it as I. Now I am assuming current through 500 ohms when only V1 voltage source is acting as I dash. So loop currents. So these are my loop currents I1 dash and I2 dash. Okay, so I think this I2 dash It should be in differential current. I think I have assumed I have written equations. Yeah, there should be it's the differential current. So I have assumed the current direction in anti-clockwise. No, clockwise. Both current directions clockwise. So I have assumed both current directions clockwise. So this is it. So this is it. This is my current, loop current. Both currents I have assumed in clockwise direction. I have short circuited. Okay, I have removed V2. So in order to remove the voltage source, we have to short circuit the voltage source. If there is a current source, you have to open circuit the current source. So since I have voltage source V2 equal to 0, I have short circuited it. So I have done everything, but I forgot to short circuit that. So, and I have assumed the currents in both the meshes. Here once again I have implemented Kirchhoff's Kirchhoff's voltage law, same, similar to previous case. So this is it, case 2, when only voltage source V1 is acting in the circuit. Okay, when only V1 voltage source is acting in the circuit, this I dash is not there, so I have just kept it. Okay, so let us assume current in 500 ohms is I dash current, and since two meshes are there, mesh 1 and mesh 2, I have assumed loop currents I1 dash and I2 dash. Okay, I1 dash and I2 dash. So I might have considered only I1 and I2. It might have been more simpler to understand, but in order to show some variation between case 1 and case 2, I have assumed loop currents as I1 dash and I2 dash. So now let us apply KVL in mesh 1. So if you apply KVL in mesh 1, how many elements are there in mesh 1? A source voltage V1 of 30 volts and resistor 1000 and 500 ohms resistor. Total 3 elements are there. Okay, so one source and two passive resistive elements where voltage drops will occur and current flows to them. So what is it? Apply KVL in mesh 1. What do you get? 1000 into I1 dash. Okay, 1000 into I1 dash. Okay, plus 500 into what? 500 into, see, the current direction. I will just expand this. Current direction around this 500 ohms. You just see this current direction is downward. This current, sorry, this current direction is upward, isn't it? Both are opposite. This is downward, this is upward. Both are opposite. Opposite means differential current will flow through this 500 ohms. So 500 into, since I have considered mesh 1, I1 dash minus I2 dash. Okay, I1 dash minus I2 dash is equal to 30. Is equal to 30. Why? Because this is my voltage source in mesh 1. There is a voltage source in mesh 1, so 30. Okay, so when only V1 voltage source is acting in the circuit, this is my KVL equation. Okay, this is my KVL equation in mesh 1 when apply KVL in mesh 1. So 1000 into I1 dash plus 500 into I1 dash minus I2 dash equal to 30. 1000 into I1 dash plus 500 into I1 dash minus I2 dash equal to 30. Just simplify it. Okay. So if you simplify it, did I write anything in the next slide? There is enough space in the next slide. So here I can expand this equation, isn't it? You just expand it, 500 into I1 dash minus I1. So sorry, yeah, this is case 3. Where is case 2? Yeah, this is it. So I have gone to some other slide. This is it. So I can expand this expression. One more equation I can write. Here instead of 30, I want to write V1. I have written one more step so that for some of you who can't think much, okay, for them it will be more easy. So here I have written multiplication symbol. It is not required actually. Okay, 1000 into I1 dash plus 500 into I1 dash minus I2 dash equal to V1. 1000 into I1 dash plus 500 I1 dash minus 500 I2 dash equal to 30. So you just expand this. I just here I1 dash is this. So 1500 I1 dash minus 500 I2 dash is equal to 30. So that I have mentioned in the next slide. So 1500 I1 dash minus 500 I2 dash is equal to 30. Okay, so that is it. Now apply KVL in mesh 2. I will just copy the circuit. So I have copied the circuit here so that it will be easy to understand the equations. So apply KVL in mesh 2. If you apply KVL in mesh 2, what is it? 2000 into I2 dash plus 500. Mesh 2, how many elements are there in mesh 2? Only two elements, 2000 and 500. Okay. So only two elements are there in mesh 2, that is 2000 and 500. So 2000 into I2 dash plus 500 into what? See, the current I2 is upward. Here I2 is upward. What about I1 dash? I2 dash is upward, I1 dash is downward. Okay, I1 dash is downward, I2 dash is upward. Therefore, okay, differential current will flow through 500 ohms. So since we have considered mesh 2, you must write I2 dash minus I1 dash. Since we are in mesh 2, when you are considering mesh 2, you must write I2 dash minus I1 dash. When you are in mesh 1, you must write I1 dash minus I2 dash. So whichever mesh you are, that current will dominate the other mesh current. So that's it. So here it is 2000 into I2. No need to write this. I have put this multiplication symbol, but no need. This is it. So 2000 into I2 dash plus 100 into I2 dash minus I1 dash is equal to what? Is there any voltage source? There is no voltage source. Since there is no voltage source, equal to 0. Okay, since there is no voltage source, this whole term is equal to 0. So 500 I2 dash, here once again I will write 500. Okay. So this is it. This is it. Applying KVL in mesh 2, 2000 I2 dash plus 500 I2 dash minus I1 dash equal to 0. Just expand this expression, expand it, 500 I2 dash minus 500 I1 dash. So 2000 I2 dash plus 500 I2 dash minus 500 I1 dash. So you can write it as, you just add these two, 2500 I2 dash minus 500 I1 dash. Okay, so I have removed that. So here you can say, you can rewrite this equation. Once again, you can rewrite it. I will just, what I will do is, so remove this minus, you can take minus common. If you take minus common, you can send it to the other side, isn't it? You can send it, so something happened. So if you send it to the other side, this is what happens. So minus, I have sent minus to the right side. So this is my equation now. This is my equation 5. So we have two equations here, equation 4 and equation 5. We have two equations, equation 4 and equation 5. So this is it, 500 I1 dash minus 2500 I2 dash equal to 0 is equation 5, and 1500 I1 dash minus 500 I2 dash equal to 30 is equation 4. Just solve equation 4 and 5, you will get I1 dash value and I2 dash value. So solve equation 4 and 5, you will get I1 dash value and I2 dash value. So I1 dash I have got 0.0214 amperes and I2 dash I have got 0.0043 amperes. I hope you are able to follow. Now let us determine the current in 500 ohms. So what is the current in 500 ohms? It is the differential current. That is I1 dash difference, I2 dash difference, I2 dash. So instead of I have written minus here, no need to write minus. You can write difference. Okay, so you can write difference. See, I have written here difference. So 500 ohms current through 500 ohms is I dash current. So I dash equal to I1 dash minus I2 dash. So I dash equal to 0.02014 minus or difference 0.0043. So you will get this I dash equal to 0.0171. So here I should not write this point and I should not write M here. Okay, this is it. So I have divided the, so I have removed this point and I have written 1000 here, and this 1000, if you, okay, and in the denominator you don't want 1000, you just write milli here. So 17.1 milliamperes. So I dash is 17.1 milliamperes. Okay, so I hope you are able to follow. Simple. Whatever we have done to for KVL, same in the similar pattern we are following, but there we didn't determine current across any specific element. Here we are determining current across specific elements. So this is the current when only voltage source V1 is acting in the given circuit. Now let's go to case 3 when only voltage source V2 is acting in the given circuit. Okay, no need to. Okay, I no need to copy and all. Everything is available here. So, okay, I have to write V2. That's it. Nothing else. Okay, I will write that. So this is a given circuit. V1 is short circuited. V1 is short circuited. V2 is in the circuit. And so only V2 voltage source is acting in the circuit. Here you can see mesh currents, mesh 1, mesh 2. So here I have assumed loop currents, mesh 1 current I1 double dash and mesh 2 current loop current I2 double dash, and current flowing through 500 ohms I have assumed it as I double dash. Okay, now apply KVL in mesh 1. In this mesh 1, if you apply KVL, there is no voltage source, only two elements are there. Two resistive elements are there. Algebraic sum of this voltage drops should be equal to 0. So here 1000 into I1 double dash plus 500 into I1 double dash minus I2 double dash Y minus. So why we have considered minus? So the reason behind that is, here you just see the current direction here in this mesh 1. I1 double dash current is upward. What about I2 double dash current? Besides to, sorry. Besides to this 500 ohms. Okay, so this current is upward, this current is downward, both are opposite direction, therefore differential current will flow through 500 ohms according to whatever loop current direction that I have assumed. I have assumed both the current loop current directions in anti-clockwise direction, isn't it? You just carefully observe the loop current directions, you just observe it is in anti-clockwise. I2 double dash current and I1 double dash current both are in anti-clockwise direction. Okay, so both the loop currents are in anti-clockwise direction. So and if you observe the current towards this 500 ohms, this current, it is upward, and this side I2 double dash is downward, so both are in opposite direction. So differential current will flow through 500 ohms. So what about when you apply KVL in mesh 1? The current through 1000 ohms is what? I1 double dash. So 1000 into I1 double dash plus 500 into I1 double dash minus I2 double dash. Why minus? Why? Because these two currents, if you observe the loop current direction, this loop current direction is like in this direction. This loop current direction is in this direction. Of course, both are in anti-clockwise. But if you observe, besides to the left side and right side of 500 ohms, on the left side, this current direction is upward. On the right side, this current direction is downwards. Okay. So even though both are in anti-clockwise direction, the current loop current direction nearby to the 500 ohms. Besides to the 500 ohms are in opposite direction. That's why differential current will flow through 500 ohms. And that is equal to not 30 volt, 30, it is 0 actually. So I think I have simply copied and I forgot to modify. Isn't okay? So it's not 30, there is no source at all. So I simply copied from previous case and I didn't modify. So this is it. So 1000 I1 double dash plus 500 I1 double dash minus 500 I2 double dash equal to 0. So 1000 I1 double dash plus 500 I1 double dash is 1500 I1 double dash minus 500 I2 double dash equal to 0. So consider it as, give some notation, some numbering. I have considered it as equation 7. So now apply KVL in mesh 2. So let us apply KVL in mesh 2. So if you apply KVL in mesh 2, how many elements are there in mesh 2? Total 3 elements are there. One voltage source V2, one resistor 2000 ohms, another resistor of 500 ohms. So this 2000 ohms and 500 ohms are resistive elements. So voltage drop will occur across these two elements. So if you apply KVL in mesh 2, so okay, I will just end the show and I will remove this multiplication symbol. So what is it? Something is wrong here. Yeah. So what is this? 2000 into I2 double dash plus 500 into what? 500 into differential current. How much? Since we are in mesh 2 now, therefore I2 double dash minus I1 double dash equal to what? There is a voltage source in mesh 2, that is 30 volts, so equal to 30. So here instead of writing 30, I can write V2. This is it. These are the equations. 2000 into I2 double dash plus 500 into I2 double dash minus I1 double dash equal to V2. So 2000 into I2 double dash plus 500 into I2 double dash minus 500 into I2 double dash I1 double dash equal to 30. So here I2 double dash, two terms are there. So minus 500 I1 double dash plus 2500 I2 double dash. So you can further simplify it. I have not done it, but you can do it. You can take minus common. You can take minus common if it and send it to the left side. That is right side, not left side. So here even if you take minus common, it is of no use. Why? Because there is 30. If there was 0, it might have been better. There is no 0 term here. So it is of no use. So for previous case, we were able to do that. For this case, it is of no use. Why? Because 30 will become minus 30. That's it, nothing else. So it is of no use. So I am not going to do it. I wanted to do it. I didn't see that 30. That's why I wanted to do it. So this is it. This is my KVL in mesh 2. Consider it as equation 8. Now solve equation 7 and 8. You will get I1 double dash using your scientific calculator. Okay, not manually. You can do manually. It's time consuming and time waste. So if you have scientific calculator, directly you can substitute both the equations in the calculator and you can solve it. So if you substitute both the equations, you will get I1 double dash is equal to 0.0043 amperes and I2 double dash as 0.0129. amperes. Okay. So I'm about to finish within 5 minutes. This class will be over. No need to worry. It's already more than 2 hours have exceeded for this class. So within 2 minutes, maybe within 2-3 minutes or 5 minutes, I'll conclude this class. Okay. This is it. I1 double dash and I2 double dash. You'll get it. By simply substituting these equations 7 and 8 in your using the scientific calculator, you will get these values. Now, let us determine the current in what? Current I double dash current in 500 ohms that we have to determine. Let us determine that. So, current flowing through 500 ohms is what? I1 difference. You can write difference or minus I1 difference, I2. So I1 double dash difference, I2 double dash difference. I have written here, I didn't write difference, I have written minus. So current through 500 ohms is I1 double dash minus I2 double dash or difference. So current through 500 ohms is I double dash is equal to I1 double dash minus I2 double dash. So I double dash is, okay. So which one was greater value? This was the greater value, okay. So if I take the difference, I won't get any. Yeah. So I'm going to have written a difference here. Why? Because so I2 double dash value is larger than the I1 double dash value. So I2 double dash is like you can write either I2 double dash minus I1 double dash or I1 double dash minus I2 double dash. I have written something, that's why I wrote my difference here. So difference of these two, you'll get 0.0086 and that is in amperes. Okay, so you can rewrite this like this and you can write it in milliamperes. So I double dash you will get in 8.6 milliamperes. So just go through it for a while, just for a few seconds, and we will verify superposition theorem. So we have determined the current flowing through the circuit, not circuit, actually we have determined the current flowing through the 500 ohms resistor when individual sources were present, and we have already determined the current flowing through the 500 ohm resistor when both sources were present. So current flowing through the 500 ohm resistor when voltage source V2 is present is I double dash, that is 8.6 milliamperes. Now let us see the theoretical proof. So what is according to superposition theorem? I should be equal to I dash plus I double dash. What did we get I value from equation 3? 25.7. What is I dash value? 17.1. What is I double dash value? 8.6. So when you add this 17.1 and 8.6, it should be equal to I. So if I add, I have got 25.7 and this also I have got 25.7. Okay, milliamperes. Okay, these are the milliampere values. I should not write, but I am writing it here. I should not write milliamperes in the equation, but I am writing it here. So both are in milliamperes. So 25.7 is equal to 25.7. So when both sources were present, okay, when both sources were present, the current flowing through 500 ohms resistor. Okay, so I will just show you when both sources were present, what was the current. So this is it. When both sources were present, case 1. So I current, how much did we get? Equation 3. How much did we get? 25.7 milliamperes. Okay, 25.7 milliamperes. Okay, and for case 2, when only V1 voltage source was there, the current was I dash current. How much did we get? 17.1 milliamperes. And similarly, for case 3, when only voltage source V2 is there, okay, so how much current did we get? Current through 500 ohms is I double dash is 8.6 milliamperes. Okay, so 25.7 is equal to 17.1 plus 8.6. Okay, so 25.7 is equal to 25.7. Okay, so current through 500 ohm resistor when both sources was present. Okay, current through 500 ohm resistor when both sources were present is equal to the algebraic sum of the currents of the current algebraic sum of the current flowing through the same resistor, that is 500 ohm resistor. Okay, when individual sources were present. Okay, so hence superposition theorem is verified for the given circuit. This is it. If you have doubts, you can mention in the chat box. If you have any doubts, you just mention in the chat box. If you were able to understand the concept, you just click on the like button, or you just any modification, anything which was not clearer for you to understand, which you people were unable to understand, you just mention in the comment section, so that next time when I make a video, I will make sure that I won't repeat that thing again and again. Okay, so just if you are able to understand, you just click on the like button if you are able to understand the concept. Someone has mentioned the question. I'm unable to understand. Can we just add the voltages? Something. I didn't understand the question. What you want to ask? I'm unable to understand. Okay. Okay then. The class is over. I couldn't understand your question. Okay. Okay then. Thanks for joining the class. Anything in the comment section you can mention. Okay, so no one has mentioned. That's why I'm ending the class. Thank you for joining the class.